Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 6 of 20. By the time a new tracking algorithm becomes a standard function in the main OpenCV library, it is often spent years being battle-tested by researchers in a separate parallel space. If you stick only to the default releases, you are missing out on the newest techniques in the field. That parallel space is the OpenCV_contrib repository. Many developers see the word contrib and assume the code is broken, untested, or strictly beta software. That is a misunderstanding. The code in this repository is often highly optimized and actively used in demanding environments. The distinction is entirely about API stability, not code quality. The core OpenCV library enforces strict long-term backward compatibility guarantees. If a function goes into the main release, its inputs, outputs, and behavior must remain stable for years. But computer vision research moves aggressively fast. Researchers need a place to publish new algorithms, rename parameters, and alter data structures based on real-world feedback. The OpenCV_contrib repository provides exactly that environment. It acts as an incubator. The maintainers of these extra modules are allowed to break the API between releases. They can rename functions or change how an algorithm initializes without violating the strict rules of the core library. Over time, a module might prove to be universally useful. Its API settles down, the edge cases are ironed out, and the community relies on it heavily. When that happens, the OpenCV maintainers migrate the code. They physically move the module out of the OpenCV_contrib repository and merge it directly into the main OpenCV repository. This graduation process ensures the core library only absorbs proven, stable technology. Consider a concrete scenario. You are building an augmented reality project and you want to use the Aruco tracking module to detect square fiducial markers in a live camera feed. This module contains highly specialized, state-of-the-art functions. To use it, you build your OpenCV environment from source. You clone the main repository to your local machine, and then you clone the OpenCV_contrib repository right next to it. When you configure your build tool, you pass a specific path variable that points to the modules folder inside the contrib repository. The build system reads this flag and compiles the core library, but it also reaches over to the contrib folder, compiles the Aruco module, and links it directly into your final binaries. You do not end up with two separate libraries. You get a single, unified OpenCV installation that includes both the rock-solid base and your chosen experimental modules. If you enjoy the podcast and want to help support the show, you can search for DevStories.eu on Patreon. It is always appreciated. The true power of this architecture lies in understanding its dual nature. The main repository protects your production pipelines from breaking changes, while the contrib repository hands you tomorrow's computer vision research today. That is your lot for this one. Catch you next time.